Welcome back, everyone. Moving on to another linear systems word problem. So one type of fertilizer has 30% nitrogen and a second type has 15% nitrogen. If a farmer needs 25 kilograms of fertilizer that contains 24% nitrogen, how much of each should the farmer mix together of these two types? So let's show this in a diagram here. So let's say this is the first type of fertilizer, and 30% of it is nitrogen, so this area right here. And then we're going to mix another type of fertilizer with this one, and then this one over here has 15% nitrogen. And what we want to get when we mix them together is a nitrogen mix, 25 kilograms of a nitrogen mix that ends up having 24% nitrogen. And so we got to figure out how much of each of these, let's call this X and Y, how many kilograms of this nitrogen, which would be X, how many kilograms of this nitrogen would be Y, do we have to mix together in order to get 25 kilograms of a mixture that is 24, or a fertilizer that is 24% nitrogen. So X is going to be the kilograms of 30% fertilizer, and then Y is going to be the kilograms of the 15% fertilizer. So notice here we could set up two equations. Basically, we know X plus Y, what is it going to equal? It's going to be the 25 kilograms, right? Because the total amount of this plus the total amount of that is going to give us the total amount of this, which is going to be 25. And then notice we could also make an equation in terms of the amount of fertilizer. So 30% of this weight of this fertilizer is going to be nitrogen. So what we can do is we could take this amount, multiply it by 30%. In decimals, that would be 0.3 times X plus 15% of this fertilizer. So this would give us the total amount of nitrogen in this fertilizer over here, which is 24% of 25. Now, 0.24 times 25, that just gives us 6. So actually, instead of writing 24% here, we can actually write 6 kilograms instead. So in this fertilizer, 25 kilograms of this fertilizer, 6 kilograms of that, or 24% of that, is going to be nitrogen. So this amount of nitrogen plus this amount of nitrogen, which is these expressions, has to equal 6, like that. And now notice we have two equations in terms of X and Y, and we could solve for X and Y. So I'm going to do that over here, and I'm going to use substitution. So let's isolate for the X. You could also isolate for the Y, it doesn't really matter. I'm going to isolate for the X, and then I'm going to take this expression, 25 minus Y, and I'm going to plug it in for this X value. So we'll have 0.3 times 25 minus Y plus 0.15y equals 6, like that. And now notice we have an equation in terms of one variable. So to solve this, we would distribute 0.3 times 25 would give us what? 7.5 minus 0.3y plus 0.15y, and that's going to be 6. I'm going to bring the 6 over. I'm going to bring both of these over. So we'll have 7.5 minus 6 equals 0.3y minus 0.15y, right? All the signs are changing. Bringing all the variables to one side, all the numbers to the other. Here, we would get 0.15y. This would be 1.5 divided by 0.15 to isolate for the y. And this would end up being 1.5 divided by 0.15 would give us 10. So 10 kilograms is how much fertilizer we're going to use, the 15% fertilizer that we're going to use. And so x. So this here, let's actually just write it here, 10 kilograms of the 15% fertilizer. And then we know that the total has to be 25, so 25 minus 10 would give us 15 kilograms of the 30% fertilizer. So those are the final answers, and then you could check your answers, right? 10 plus 15 is 25, and then 0.3 times x, which is 15, would give us 4.5, and then 0.15 times 10, the y, would give us 1.5, and notice how that indeed is going to give us 6. Left side is going to equal right side. So in both equations, it verifies, it checks out, so we can be pretty confident that that is the final answer.